Solar panels are getting better and cheaper. Inverters, which deliver the AC power, are also cheaper and last longer. Grid-tied systems work perfectly and have a huge efficiency with almost no waste. Everything is recorded in the user's account. You can now capture every watt of solar power, and the capacity of the system depends solely on the power delivered by the power company and not on the size of the system. But have off-grid systems reached the same efficiency level? Let's see. Solar panels are practically the same. The difference starts at the charge controller. This device manages the energy delivered to the storage batteries. Although this device is very efficient, it can only store energy in the batteries while they are not fully charged. Once they are full, the panels keep delivering power. Unfortunately, there is nowhere to store it since the batteries are full. This means we can lose as much as a half day's radiation. Batteries are costly and shortly lived. You can install a whole lot of them and the system might work almost perfectly, but the initial cost is very high and a few years afterwards you will have to replace them, and whatever you saved will be lost. Batteries are generally of the lead acid type. They can last about 5 to 10 years. And then they are sulfated and are no good anymore. Then there's the problem of sizing the system. An off-grid system depends on the capacity of the inverter as well as the batteries as to the maximum instantaneous load it can handle. Suppose we have a 1500 watt system which has the appropriate elements for continuously delivering such power and still store some in the batteries. It may occur that a large instantaneous load comes along, which is frequent, and the system may collapse. If someone turns on the coffee maker, 1200 watts are being drawn from the house wiring, and then a bread toaster is turned on and suddenly the fridge kicks on, the system would protect itself and turn off, so you would have to reset it. In the case of a grid-tied system, this cannot happen, because if the system is exceeded by the energy being drawn, the additional required energy is taken off the power company line, and the only amount charged to the user will be the difference. That is, you will pay something, but much less than the total power used. However, a grid-tied system stops working if there is a blackout or a glitch from the power company, whilst battery system keeps operating even in case of a power outage. That is why a battery system provides an independent supply which can keep alive a computer system or a radio transmitter with a higher priority, or else being the sole power supply in sites not reached by the power company lines. Batteries are very useful but very inefficient and short-lived. An interesting alternative are supercapacitors, but they would have to be extremely big and costly for the same charging capacity as batteries, about 100 times higher. As long as the ideal battery is not invented, a battery you would never have to replace, not being bulky or heavy, low cost, and which does not damage the environment in case it is destroyed, energy storage will still be the weak link in all independent power generation systems. To date, the most effective means of saving money and protecting the environment is the grid-tied system, which highly reduces pollutants. For the time being, we can greatly reduce the use of electricity, as well as the gas bill, by using electric heating instead of gas. Thanks for watching. Please subscribe to my channel.